find the sine and cosine ratios of an angle of a right triangle if the tangent ratio of that angle is 5/12 or 5/12. Again, it says find the sine and cosine ratios, that's 2, of an angle of a right triangle. Boy, a lot of angles in there. And if that tangent ratio of that angle is 5/12 or 5/12. Let's just take a look at what that's all about. A little bit of trigonometry. Some of you are going like, what is that SINE business? And what's that COSINE business? Those are what we call sine and cosine. They are ratios having to do with an angle of a right triangle. So I've drawn a picture here to help us out a little bit. So we've got this lovely leg, a leg and a hypotenuse. It's a right triangle situation. Now, what we've got to remember here is, what does the tangent in a right triangle, what is that all about? And it's saying, first of all, we're going to pick two sides. And being tangent, that is going to be, folks, that's the opposite over adjacent. Those are the legs we're talking about. And I you know, what we're going to do here, you say, well, Ernie, how are we going to know what to do? It says, obviously 5/12, let's put 5 with the smaller side, smaller leg, if you will. And let's go with 12 right there. That's the first thing we notice. It's the first thing we notice, all right? Now, in looking there, it asks, find the sine and cosine ratios. Well, there's one catch. One catch. We don't know what that hypotenuse is, and that's important for us to get to the sine and the cosine, all right? So a little bit of trig here, but that's actually a little bit of Pythagorean. Y'all remember that a squared, b squared, c squared business in a right triangle? Here's where we're going to use it. So right over here to the side, I'm going to write 5 squared plus 12 squared equals c squared. By the way, that c is going to be my hypotenuse there. I don't know what it is, but we're going to find it. It's not going to be hard to find. So we square the 5. Everybody knows your perfect squares out there. I hope. That was actually your multiplication tables. 5 times 5, 25. Then we got 12 times 12. That's what 12 squared is going to give us, about 144. Actually, it's exactly 144. There you go. And we're going to add these things together in order to figure out what is c squared. Now, keep in mind, back here we want to find out what is c. But we'll play with c squared first to get to c, all right? So adding these together, 25, 144 gives us 169. That's a good thing. That's a good thing. You say, why is that a good thing, Ernie? Watch and see, watch and see. Because when I take the square root, oh my goodness, we got c, and we got the square root of 169. By the way, we want the positive because we're talking length of a triangle here. So we're not looking plus or minus here. We're just going to use the positive version, which, by the way, that's a perfect square, which means 13. So that gets us halfway home. We need that value right there. So again, first thing you need is a picture. Second thing you need is to figure out the missing side. And now, folks, we're talking about this angle right here. What angle has the ratio of 5/12? That's the opposite leg over the adjacent leg. That's what tangent is all about. Now, what we want to do is take, I'm going to call this thing A. It just makes it a little bit easier, angle A down here. We want to find out what is the sine of A. And by the way, we write sine A without the E. It's just an abbreviation. If you look on your calculators, most of them have that SIN. That's what it is. It's just short for the word sine up here. And then we're going to also look for what is the cosine of that angle, A, all right? And in words, the sine is equal to the opposite leg over a ye old hypotenuse, all right? The hypotenuse there. So opposite is 5, and that's going to be over 13. That's your sine ratio, all right? That's your sine ratio. The cosine ratio is the adjacent leg. Folks, here's the A. This is the adjacent. It's the leg that ties into angle A, all right? It becomes one of the sides of angle A, if you will, here. And that is going to be 12, and again, over hypotenuse, 13. So again, kind of writing this thing, this is called the opposite over the hypotenuse. This one is called the adjacent. And by the way, those are legs. Those are legs, okay? And this one is over the hypotenuse. Remember, the hypotenuse is always the longest side of the right triangle. It's also the one we look and see it across or opposite of that right triangle, that right angle right there. So there's your story. Those are your ratios. You say, well, Ernie, what good are those? On down the road, you can take and find out what the degree measures are inside these things. What are the angles that this hypotenuse is making with this horizontal, or also vice versa up here, all right? And another thing, by the way, 5/12, you know, if we were to do it on this, It's kind of like a slope. So these sine, cosine, tangent ratios have major ramifications on down the road for you, all right?
For more math help, visit TNLearn.org.